Welcome back. Previously we had discussed about addition concept and conditional probability. Let us discuss about other rules of probability. Next one, multiplication rule of probability. Just like the method which we have learned in case of an addition rule of probability, in multiplication also there are two situations. One with regard to events that are dependent to each other and another with regard to events that are independent to each other. Just like the mutual and non-mutual cases which we have learned in case of addition rule. Okay, let's come back to multiplication rule. It is quite different from that. It also has two situations. One is multiplication rule for any two events, especially in case of dependent events. If A and B are any two events, then the probability of both A and B to take place together is denoted by P within brackets A intersection B. Remember, in case of addition, the equation is quite different. In case of multiplication also it is different. Okay, we are not going to mix both the cases. In case of multiplication, P of whatever the multiplication case is represented by A intersection B. So, if A and B are two events, then the probability of A by B equal to P of A intersection B divided by P of B. The same can be written as P of A intersection B equal to P of B into P of A by B. There is nothing new with that. The thing is, you just cross multiply it. So P of A intersection B equal to P of A by B into P of B. That is the concept with regard to this equation. So whenever you come across a situation where multiplication rule of two events, especially dependent events, the one equation is like this. So why there is one and two equation? Because the situation can be A by B or B by A. So if it is a case of A by B, the equation is like this. If it is a case of probability of B by A, then the equation is like this. Why there is a situation of A by B and B by A? Because we are learning the situation of events that are dependent to each other. Whenever there is dependence between events, that situation is related to conditional probability. Because we have learned about A by B, B by A in the case of conditional probability. Conditional probability is applicable in this multiplication situation of dependent events. That is why there are two situations with regard to multiplication rule of dependent events. Whenever you come across a situation where A by B, the equation is probability of A intersection B divided by probability of B, which can be written as probability of A intersection B. Actually, this is the equation that representing the multiplication of two dependent events. That is probability of B into probability of A by B. Similarly, probability of when you are studying the events with regard to B and where the condition is represented by A, it will be written as probability of B by A equal to probability of A intersection B divided by probability of A. So it can be written as probability of A intersection B equal probability of A into probability of B by A. So these are the two equations that are similar to the condition probability situation, where multiplication rule for any two events, usually events that are dependent to each other, comes, you will be using this equation. And just like this one, there is another case also that comes under the multiplication situation, when multiplication rule is applicable in case of two independent events. If A and B are two independent events, then the probability for both A and B to happen is the product of their probabilities. It's very easy, one of the easiest equation with regard to addition or multiplication. This one is very easy. whenever you are dealing with independent events, the probability of A intersection B, usually in case of multiplication, this one will be the same, A intersection B, and in case of addition, it will be A union B. That is a difference. Remember that. So, probability of A intersection B is represented by just multiply the events under study. Here we are studying only A and B. Sometimes you come across a question where it will be 3 events or 4 events or 5 events. Just multiply all those events. We will come to that part during the practical area. During practical cases, we will be discussing many situations. So, this is how you have to deal with the situation with regarding multiplication rule in case of 2 independent events. Equation is like this. So, familiarize the equations which we have learned until now. Main 2 equations which we have to deal in the application part is probability with regard to addition function and probability with regard to multiplication function. Remember, in probability situation there will be 2 cases, that is mutually exclusive and non-mutually exclusive. In case of an addition multiplication situation, there are 2 situations, that is probability in case of dependent events and independent events, and under dependent events there are again 2 equations with regard to that. We are not going further into that because we have already discussed that part, so not going to discuss again and again to get you confused. So let us go to the practical cases, then you will get a clear picture regarding that. Probability that A will pass paper 1 is 0.3 and probability that he will pass paper 2 is 0.7. What is the probability that he will pass both the papers? So what is the answer? So first of all, you need to identify whether it is a situation of mutually exclusive or a case of independence or not. So how you are going to identify whether it is a mutually exclusive cases or a independence or dependence case? You have to use the simple logical sense, because mutually exclusive means one event, if one event is happening, other will not happen. Independent or dependent situation means one will be followed by 2 events may or may not occur. One may be dependent to each other, one may not dependent with each other. What the situation like is likewise. So here you have to study the probability that A will pass paper 1 and paper 2. So what is the probability that he will pass both the papers? So it is a case of multiplication situation, because here paper 1 and paper 2, there is no statement mentioning that if the failure or the success rate of paper 1 depends on paper 2, or if he is passing in paper 1, paper 2, he will definitely fail in paper 2 likewise. So it is not a mutually exclusive situations, because anyway the result of the paper 1 and 2 will come. That is, occurrence of result of paper 1 will not lead to the withholding the result of paper 2. There is no such situation. The result might come. What is the result? Whether it is a pass situation or a fail situation, that is the event we have to study. So it is a situation of independence. That is, independence or dependence, actually that comes under the multiplication situation. So whether the events are independent or dependent, how you are going to identify? Independent means both events are not related to each other. The event of the result of the first event and the result of the second event have no relation. Here though there is no statement regarding that if he pass in paper 1, he will fail in paper 2, or if he pass in paper 2, he will definitely fail in paper 1. There is a relation between paper results. There is no statements like that. So we can prove that this is a case of multiplication rule, under which it is a situation of case of independent events. So this is how you need to identify a case. Usually it may be specified in the question, but if you are unlucky, it may not be specified. Your logical sense has to be used to identify whether it is an addition case or a multiplication case, or whether it is a situation of independence or dependence, or mutually or non-mutually situations. So it is a case of independence. So in case of independence, the equation is the most simple and easiest one. Probability for passing the two paper is probability of A intersection probability of B equal probability of A into probability of B. You will get 0.21. So it's very easy to identify. The only thing is that you need to identify whether it is a addition case or a multiplication case. You need to identify that. Next one. The probability of A is given 0.4 and probability of B is given 0.3 and probability of A intersection B 0.2 is given. Find the probability of, first one, at least one of the event to occur. Second one, exactly one of the events to occur. And finally, no events to occur. In other sense, it may specify that none of the events to occur. That is the meaning. So three questions are there: probability of A, B, and probability with regard to A intersection B, both the events. 0.2 is given. Find the probability that at least one of the events to occur. So how we are going to deal with? I hope in the beginning of this module we have discussed many terminology factors or terminological terms with regards to probability, and we have discussed briefly about the meaning and concept of each of the terms, and we have discussed about this at least one event concept in one of the theoretical area. So probability of at least one means P of A union B, means at least one means any of the events. Here there are two events, A or B. At least one means any of the event from A or B. That is the meaning of P A union B. So the equation is P of A plus P of B. You may think that we have learned this P of A plus P of B in case of addition case where mutually exclusive situation come. In this question there is no specification regarding whether it is mutually exclusive or likewise. So the equation will be P of A plus P of B minus P of A intersection P of B. This is the equation with regard to that. I hope we have learned the same equation previously in case of non-mutually exclusive events. So whenever at least one situation comes, remember that comes under the addition rule of any of the two events, especially non-mutually exclusive events. Remember that this is the equation regarding that particular category. So in the question, P of A is given, P of B is given, P of A intersection B is given. So you can directly substitute everything in the equation and you will get 0.5. So you have got the probability in case of at least one. Remember this one. We will come to this part just now. Next one. Exactly one of the events to occur. Exactly one of the events to occur. The meaning of that also, I think we have discussed the same area during the explanation of various terms with regard to probability part. So exactly one of the events to occur is, it is represented by P of exactly one of the events to occur is represented by P intersection B dash union B intersection A dash. I think you may have got the idea if you have gone through the previous sessions. The concept of this probability is that exactly one of the event to occur means if A occurs, B will not occur. And at the same time, you can come across a situation where B occur, in that case A will not come, because that is the meaning of the sentence, exactly one of the event to occur. Here we are studying two events. So if one event occur, other will not happen, and if the other occur, the other will not happen. Here A and B are under study. If A occurs, B will not happen. and here you have to study exactly one of the events. So A and B have both equal importance. So when A occur, B will not happen. That is represented by A intersection B dash. Or it may be like this: if B occurs, A will not happen. So that is represented by B intersection A dash. So remember, exactly one of the event occur. This is the equation, and we can expand these two areas in order to directly substitute the values. So it is like this: A intersection B dash is represented by P of A minus P of A intersection B, and B intersection A dash means P of B minus P of A intersection B. Remember, here there is one union. I have mentioned that when union comes, that means or means plus sign. Remember that. So we have expanded these two areas. I think now we can directly substitute the values, because P of A is given, P of A intersection B is already given in the question, P of B also given, again P of A intersection B, it is repeating. So just substitute the values in the equation, you will get 0.3. So remember the equation. During the various case studies, there will be equations with regard to the situation under the study. Even though we have learned the equation with regard to multiplication as well as addition and some of the other equations which we have learned previously, these are the equations that comes into handy while leading practical cases. And finally, last one, none of the events to occur. There is a simple equation for that. When none of the events occur means A or B, both will not occur. So the meaning is A dash intersection B dash. We have learned about A dash and B dash. They are complementary situation. Whenever the event that does not occur is represented by A dash or B dash. Here in the question, none of the events occur. So it is represented by P of A dash intersection B dash. So I hope you know how to find A dash and B dash. If you know how to find A dash and B dash, it is fine. You can go with that. But for the time being, I am giving you an easiest trick for finding the probability of none of the events occur. Whenever that comes, you can use this equation: 1 minus P of A union B. If you have the logical sense, you have got the or you understand the concept why we are used to 1 minus P of A union B. Previously I have mentioned that if you want to find the opposite of something, you need to deduct that from 1. In the question you have to study none of the events occur, means A or B, any of the events, they will not occur. So the opposite of that means any of the events will occur. See, at least one, that is the opposite of this one. So if you want to find the value of this one, just deduct this value from 1. Or if you are having the value of this one, you need to find the value of at least 1. Just deduct this value of none of the events occur from 1. That is the simple concept between these two events. Here at least one of the events will happen. Here none of the events will happen. That is the opposite of these two. So none of the events occur means 1 minus at least 1. Any of the event. Here none of the event means nothing will happen. Either A or either B. Anything. Nothing will happen. So at least 1 means 1 minus none of events occur. Here you are asked to find none of the events occur and you know the value of at least 1. So 1 minus at least 1. This is an important equation. Remember that. And we have already found P of A union B, value is 1.5. So 1 minus 0.5, you get 0.5. So this is how you need to find the value with regard to probability and the multiplication rule and combination of both multiplication as well as addition. And remember the equation that comes under the various practical cases, because you have to familiarize this equation with regard to the situation under study, because you may come across different situation like this where you have to use these equations. So familiarize the equations under study, understand the concepts and cases. We will discuss about the further cases in the coming sessions. In the next case, what is the probability that A solves a problem in statistics is 2 by 5 and the probability that B solves it is 3 by 8. If they try independently, find the probability that both solve the problem. That is one question. Another is none solve the problem. And finally, at least one solves the problem. The question may be quite tricky, but the concept and the methods which we have learned previously, we have to use those methods and concepts. Try to identify the value for this one. Until then, go through it, find the answer. We will discuss about the same topic in the next one.